Okay, welcome back to the last stage of LINX120. I'd like to welcome to the stage now, we've got Jan-Willem Nijman from PelicanCorp. And he's going to be talking to us about advancements in utility mapping. So welcome to the stage.
Thank you, Jeremy. So, maybe a question before I start. Who has anything to do with, let's say, or is involved in, let's say, the physical design and, let's say, the construction of fiber in the ground? Yeah, okay, that I understand. Okay, good to know that at least. By the way, I got a lot of questions while I was in the UK about this. I didn't fight, by the way. I didn't fight in the UK. It was just an accident during squash play, so on Monday evening. Too fanatic, by the way. A new approach of utility asset sketching process. So that has to do with the physical assets that are in the ground. And I guess most of the presentations, what I've seen today, of course, are much more about, I would say, the network itself, or let's say the equipment in the network, I guess on the software around it. I heard a lot about speed of networks. But I think a lot of people always forget is, of course, what is physically in the ground, which is very vulnerable, basically. Also was a presentation about DDoS attacks and stuff like that. But the reality is that the networks in the ground are often under another attack, excavation attack, I would call it. In the UK, I think there's an estimate of, let's say the 4 million excavations every year in the UK, and that's growing. And I think the estimate of the amount of damage is around between 150 and 150,000. Now, I guess that half of that, or maybe even more, is relating to data networks, fiber, which is between 50 and 75,000, which is probably about something around, let's say, 150, 160 a day of damage of a network. And many of them, of course, are not maybe important. Some will. But that's a huge cost, of course, if you think about it. And it's not maybe so much the direct cost, but it's more the indirect cost, loss of revenue, reputational damage. And that's particularly, I think, for fiber companies, or for companies that run with fiber, particularly important. I mean, nowadays, 20, 25 years ago, fiber was, or let's say internet was not important. Nowadays, it's a critical network. So why is then, for example, sketching, or let's say accurate sketching important? Today, I think lots of the networks that are basically put in the ground are not really accurately mapped. And accurately mapped, I mean, let's say within centimeters accuracy. And that basically means that if you think about that, let's say if the networks would be mapped really accurately, then you could actually put a VR reel on your head, and you could see where these are in the ground. And today, of course, that's absolutely not possible. You might be lucky if a network is somewhere meters away where you think it is. That's not only in the UK, that's everywhere, and also where I'm from, the Netherlands, by the way. And the pity thing sometimes is there is a lot of new networks put in the ground, and still in many cases, the mapping basically of that is still not really accurate. And some maybe disagree. I think some might have it in order, but I think in many cases, when I talk to companies, it's really, it's really not really well done, basically. And that's what this is about. Now, this is an example, by the way, of a telco operator, which is in the country where they are a pretty large one. But the country itself is not so big. It's less than 10 million inhabitants, and they do only 200,000 excavations in that country, which is, comparing with the UK, 4 million is rather small. But still, they have 14,000 damages, basically, costing them 10 million. And a part it has to do with the accuracy of the network, how they put it in the ground. Another part, of course, has to do with behavior of people. And of course, sometimes people don't know if they start excavating which networks there are in the ground. In the UK, actually, there is actually quite a good service, by the way. And if you, I guess there are some fiber companies here around who basically protecting these networks. One is line search before you dig, alice.co.uk. Maybe some of the companies here are a member of that service. Basically, what that service does, if a contractor wants to excavate, they go to their website, they draw their excavation site, and they will get in return basically a response which network are in that area. And they get plans of those networks as well. And of course, that only applies for the asset owners that are member of that service. But at least that's a very, let's say, proactive approach of informing people, companies that do excavations, who is around there. And the other way, of course, is basically better documentation of the network itself. I already mentioned it. This is actually an interesting example. This is an example that happened, I think, 2 years ago in the UK, somewhere, I think, not far from London, I believe. It was an excavator who was drilling, and I think they ripped out quite some fiber cable. I think this cost, 80,000 house without basically internet for quite a while. I think the guy was still smiling by the way. I'm not sure afterwards how it was, but that's a whole other story. I think often when I talk to companies about this, they say, well, okay, we can recoup some of the costs, some of the repair costs from the guy who did it. Of course, the reality, I think, if you think about the other parts of the cost, which is more indirect, reputational, loss of revenue, that's a far bigger impact, by the way. In fact, the University of Birmingham did a nice study about this, and they came to, I think, an estimate of something like that the indirect cost is average 29 times more than the direct cost. So the direct cost is repair cost, and the indirect is lots of other cost components. I think you can still find it, by the way, that report. If you look for, I think, the University of Birmingham, if you want, I can send you the link if you mail me that, if you ask me that later on. In the beginning, I said, okay, I estimate that in the UK, the number of damages on data networks is about 50% of the, let's say, 100 or 150,000 damages. The reason I said that is I based it on the Dutch case. This is the damage report in the Netherlands, which is quite accurate, by the way. This is probably, I would say, 90% of the damage in the Netherlands are reported to a regulatory body. And of course, this is in Dutch, so you can't read it, but this is saying data transport, which basically says it's just over 50% of the total amount of damages, 26,000. So my assumption is that the UK is not much different, by the way, than that. Giving you this number of 50,000 or maybe 75,000, because the damage reporting in the UK is not really centralized. Every company does it on their own way. Now, one of the things when we look from, let's say, an as-built situation, from what is built in the ground and how it's documented, is that in many cases there is no standardized workflow. With that, some fiber companies that work often with multiple contractors that put the fiber in the ground, and these contractors all have their own process basically. Then, of course, one of the other challenges I think that is often occurring in this process is that it can take quite a while before that documentation is done and before it's actually in your own systems. With that, I mean having it in, for example, geographical information systems or any other system where you basically have the assets that are in the ground. And then, of course, the data quality. Data quality, one of them, of course, is accuracy. How accurate is that information mapped, in fact? And how is it specified in the first place and controlled? In many cases, there is also a lot of post-processing. Data that is captured in the field by guys in the field, basically, can be maybe drawn on a piece of paper. It has to be digitized in an office. And of course, that's done by your contractors in many cases, or subcontractors, but then it has to go to your office where it has to be processed again quite often. And not to speak about, of course, that there's still a lot of paper-based processing. So this is what I still see a lot, by the way, how it's documented, and then it's how it's going into an office. And somebody then has to translate this into a digital format. They have to understand what has been scribbled on paper. And sometimes it's a combination of maybe Excel or any other offline tool, even making photographics aside, and that has to be combined in an office. Error prone, of course, and also very time consuming. Now, wouldn't it be nice, of course, if you can do it this, that you sketch basically on an app, but also by the field crew itself. In many cases, this is still happening that, for example, a surveyor will do this work, that the surveyor will come by and do the documentation part. And actually, that's not really necessary for this type of work when you have to do as-built of basically, for example, fiber assets. This is how it's often happened already now, either using a mobile phone for basically capturing the data and sketching it, or in this case, basically, where the guy in the middle actually is basically documenting a fiber cable and using a GPS device. And this is just the guy that is of the gang who is basically has built the fiber network. And what you see here is basically allowing you centimeter accuracy of what has been put in the ground. Now, one of the topics I want to talk as well in my talk is about a kind of collaboration, because you deal with multiple contractors in many cases, and how can you make that in a good collaboration? And two cases. One is the Netherlands itself, which is a pretty large case, by the way, and the second one is a smaller case, which is a fiber company, not in the UK but in another country, which have a collaboration way of working with their contractors. So this is basically the house connection process in the Netherlands, which is basically today is a full digital end-to-end process. And when you talk about house connection process, in the Netherlands you talk about on a yearly basis 60,000 houses, and then you have renovations. So let's say you talk about 80 to 90,000 houses where you talk about connections that have to be done again or are new. I'm assuming that in the UK that's much higher, by the way. Must be a couple of 100,000, I imagine, by the way. When I look in the past, and I'm talking here about more than 10 years ago, it was a very inefficient process. Every utility, every fiber company had their own way of doing it. And so, and it meant also that multiple contractors quite often were active basically in that process. It took quite a while before this information was actually visible in plans, in the utility or in the fiber companies. And of course, it was still a very manual process. And then, most obviously, there was a lot of work also in the office of these utilities and fiber companies, if you can imagine that. So the guidelines by that time, by the way, in some parts of the Netherlands, there was a discussion, okay, how can we make this total process much more efficient, basically? And how can we get a closer working relationship between the asset owner and the companies, the contractors that basically built the infrastructure? So the whole idea here was, instead of every time going for the lowest bid, assign a contractor for a period as a kind of concession for a certain area, 3 to 5 years, based on also, of course, the quality of work that he would provide. And going for a full digital process, basically, so no paperwork whatsoever anymore in this whole process, from design into the, let's say, to the contractor, and then going to the field and back. And of course, accurate as built. In this case, you talk about centimeter accuracy, capture of data of how it's built in the field. The other thing was basically that the data should be available, visible basically in a GIS platform or any type of system basically that the asset owners were using in about a month's time. And the reason behind that was basically to reduce strikes, because if you put, let's say, infrastructure in the ground and it takes, let's say, a year before it's actually in a plan, that in that year, if somebody starts excavating, he doesn't know that there is a new cable there, so they will hit it. Eliminate, I think this was particularly interesting for the asset owners, eliminate basically any post-processing. This was actually guided for reducing the amount of headcount in GIS departments. which at that time was a pretty consuming, big departments in many cases. And it was also resources that are very hard to get, particularly if the working population is aging and people are retiring. And okay, combine it with other kind of things that had to be done, by the way. Nowadays, it's called basically the digital blue-collar worker. I mean, in Dutch, it's a bit different, by the way, but I translated it here in English that way. I'm not going to the whole process because this is nowadays a process which runs in the whole of the Netherlands, basically, between utilities and contractors. I only want to concentrate on the middle part, the yellow part, the guy that's in the field. How does he work, basically? How does he nowadays? And quite often you hear things like, yeah, can a blue-collar worker, can he do that? Is he capable of handling such a process? Yes, the answer is yes, because I think the guys that we have working in the streets are not much different than in the UK, to be frank. So basically, a person in the field, in most cases this is, let's say, the guy that's heading of a crew in the field or a gang, what I think it's called in the UK, will have an overview of normally what jobs he has to do. And then it will show a little bit, let's say, about details of when it has to be delivered, what kind of assets are involved, basically. Is it only one or it's multiple assets that has to be installed? And then basically he starts constructing actually what is built. And so first of all, he has a design in the system on his app. So he has the design of the connection of, in this case, of a house. But then he will basically have to construct it. So he's constructing either with using a GPS device, which is the easiest way, or he is constructing by using chain offset methodology from measuring from the house. Because the house, and probably it's the same here, that's measured basically, normally that's pretty accurate in terms of a location of of the side of a house. And then basically what you see on the right side are the different types of assets that he has to collect and that he has to basically map in the system. So it's not only, for example, a fiber cable, but it should be also from any object that needs to be connected to that fiber cable or any other object in that matter. So then looking for where we are today, basically. So this whole process is now, initially it started in one province in the Netherlands, and this is now basically active in the whole of the Netherlands. So every contractor nowadays working on house connections and working for, let's say, utilities or fiber companies is basically using this process. It's a collaboration process where, of course, the whole aim is to make the whole process faster and also, of course, to reduce any unnecessary steps, I would say. You could say this is a kind of lean process if you think in Six Sigma type of processes. So getting any unnecessary, call it waste, out of the whole process. The turnaround nowadays, if now a new connection is executed, is 6 days. So it's done. The data is collected. It's reviewed. It's qualified. And after 6 days, this is visible normally in a GIS, in a geographical information system, on the client side. It's of course a complete paperless process. There's no paper anymore that you see on working sites in these locations. And of course, then the other thing is the accuracy of what has been built. And this last one is particularly driven, by the way, for reducing damages, and of course also for maintenance purposes in the future, because most of these networks, and I guess that's the same with your networks, they are existing for many, many years, 10, 20 years, whatever it is. I mean, I understood from BT that the copper networks are probably more than, 40, 50 years old. And then the other thing, of course, drive to combine multiple connections in one workflow, opening the street only one time, getting less hassles with councils and that kind of stuff. So this process, of course, is a very lengthy, it took a long time basically to implement this, as you can imagine, because it involves lots of companies. It means also you need to have very strict guidelines, what you can change. For example, some changes can only be done once a year. Because of course, it's all based on conventions that are put in this whole process. Otherwise, it won't work. And that means, of course, also that it has some inflexibilities in it. Absolutely. The other example, as I mentioned, that I think because the first one is a very large scale. And of course, that is not really, you need to have a group of companies that say, look, this is a great idea, this is how we can basically cut down our costs in the whole chain. Mind you, by the way, in the previous one, particularly, I think the savings, if you call it from the utility side, and that's the asset owner side, was particularly on GIS resources. There were utilities that could actually save on 30 FTEs during the course of this project, so that's massive, by the way, if you think about that. But for the contractors, basically, for them, it's basically more stable type of income and also quicker way of invoicing, by the way. That was the other outcome for them. Now, on a smaller scale, because when I'm talking to from let's say mid-sized, smaller fiber companies, the issue that you have with particularly companies that put fiber in the ground is that these companies are often very much cash flow driven. I'm not sure if you have that experience, but their aim is to put as much fiber kilometers in the ground as they can, basically. They're working normally on speed. Of course, that is conflicting sometimes with quality, by the way. And while these companies are so cash flow driven, it's for them also difficult, I think, to invest in new technologies, basically. It's often, of course, they're very cost conscious because it's all driven to get the lowest price for the let's say, per kilometer fiber. So then that means that other things become under pressure. And one way to overcome that, because for let's say the asset owner, their interest, of course, is that the documentation is done in a proper way. Because after all, this network is there for maybe the next 10, 20 years. There needs to be done maintenance. You want to be sure that you want to know actually where it is, because it's an asset. And I guess it's probably one of the most valuable assets what you have in the ground, actually. So one way to do that is actually, and this is an example, for example, in Luxembourg, where one of the main fiber companies use a system, well, it's basically our system, and basically give the context that they use, they have access to their field clients, to their apps, basically. So they use, when they work for this fiber company, they use the licenses for actually mapping the hardware they put in the ground. And the benefit for the fiber company in this case is that they have immediately, let's say, accurate documentation of that network, and they don't have to do any post-processing. And so they basically, this is the Lux Connect. This is the state-owned fiber company. They are the main fiber company in Luxembourg. Part of that is also dark fiber, so very probably costly fiber, in fact, what they have. So what they basically do is give out those tools to their contractors to do that documentation in an accurate way. So they actually map their networks with centimeter accuracy. And one reason for them is also to prevent damages to the network, to make, let's say, at least from their side, to take responsibility for what they do, and that they also know where the network is, that if they have to do maintenance, that they don't have to spend a lot of time to search where is that network. And then the other thing for them, which is important, is of course what has been captured, they can also export into their cable management system that they use. In their case, it's called Cable Scout. And I'm not sure if that's a familiar brand in the UK, but it's a system for managing all your, let's say, your cable routing and stuff like that. So, I'm almost to the end of my presentation. So I wanted to share a little bit in the beginning about, the other challenges that there are, apart from the, let's say, more software-oriented things on networks. So I talked something about damages that take place of excavations. Like I said, I mean, in the UK, it's not really very clear how much damages there are. Is it 100,000? Is it 150,000? I would say in the Netherlands, it's almost 50,000. The UK is about 3 to 4 times larger in size in terms of economical power and people. So I would imagine that it's closer to 150,000 to 100,000, but okay, that's just my guess. And like I said, I think half of that is basically hitting fiber cables. And one of the ways I believe that what can help is basically document a network in a proper way, in an accurate way. And of course, that incurs maybe some additional costs. However, if you look in the reality of the cost of putting a network anyway in the ground, you're talking about basically about peanuts. And on top of that, if you apply a digital way of collecting data and documenting it, you can actually collect a lot more information that might be priceless in the future. So you can, for example, take photographic evidence which is connected to your network. You can take all kind of field notes, whatever you... I mean, there's a lot more information than you can actually collect than if you would do it in another way. And it might be not relevant for now, but maybe that's relevant in 5 years from now. Okay, the tooling that we bring to the market is called GeoLentis 360. I think it can do a lot of things, basically. It's all about utility mapping, where it has been designed for. It has specifically designed, basically, to bring utility mapping to basically the blue-collar workers. So not the surveyors, but really the blue-collar workers, the guys that basically are working in the trench. And this is nowadays, if I'm looking in the Netherlands, this is nowadays, it's not only our solution by there, but this is nowadays the way contractors work in the Netherlands. Paperless, I'm not saying that surely there will be companies that will still have some paper, but in the majority of cases, people use apps for basically documenting the networks. Okay, I'm at the end of my presentation. Any question?
We have a question over here.
Hi. So this is getting the documentation right and accurate and things like that. Are there any innovations in actually mapping what's already there? You know, like deep penetrating X-ray run from a fleet of drones that you can have running 24/7?
Of course, you have ground penetrating radar, which is already an old existing technology. Only with fiber, I don't think that works very well, to be frank. I mean, if it's probably, and then of course you have electromagnetic devices, but that works best actually with something that has metal in it. So most likely it's GPR that would be used for that type of technology. Apart, some of these devices we can actually connect and capture it from. So yes.
Thank you.
I was sort of wondering, in terms of having a sort of public website like this, does anyone see any security issues regarding people saying, well, okay, I want to find out where the fibre that happens to run the telehouse north thing, so I'll pretend I have to run a fibre line and let's go and ask what's nearby, get a readout of what's nearby, and then, 6 months later put a bomb there. Does anyone do people think about that or see that as an issue with having the sort of open process?
No, I don't think so. I think in generally, I mean, if I'm looking, I mentioned in the beginning, for example, the service that is, if you excavate it, you can go to a service where you actually create a dig site, and then you get in return basically a list of asset owners that are in that area. And on top of that, you get a plan. And I know that there are some in that, for example, the Alice Butt service, there are quite some fiber companies are part of that. So they basically send a plan. And I don't think I think they're more concerned that their networks are hit, basically, because that's a much bigger cost than the fact that people would make abuse of it. So, and the same is in my country, by the way. So I don't think that's a real concern, by the way. It might have been in the past, but not nowadays anymore.
Oh, we have one more question over here from Tom. Oh, sorry. Yes, yeah. Sorry.
So the people you're citing were more, state and telco level stuff. This sounds like this is too expensive for small altnets to use. Is that true?
No, I think no. The only thing I think is probably that larger fiber companies are probably, I think they might use it, or some might use it already, some of these technologies. And I think larger fiber companies may have more leverage to push their contractors to go to work in the way they want. I imagine that, for example, BT, they have much more leverage than, let's say, the rest of the fiber companies in, for example, the UK. That's my guess, by the way. Is that answering your question or not? I don't know.
Well, you wouldn't know unless you knew exactly what the price was, but you're suggesting it's actually economical for small providers to use as well.
No, it is because I think, for example, Lux Connect, for example, is not a huge company. They use it. And I think you're not talking about here hundreds of thousands of pounds, for example, not at all. This is technology which can start very small and can grow. I mean, you can start this basically with a couple of people in the field. And let's say we have many companies basically that work that way. So we have let's say contractors that are small companies, and of course we have companies that are larger basically with a lot more crews outside.
Okay, thank you. Yeah, Justin racing to the back of the room there for Tom.
Hello, Tom Rigg, Broadband for the Rural North. Are you aware of the government initiative called the National Underground Asset Register? Right, because we engaged with these guys early on, and they're trying to put all of this data together, and obviously all the operators are collecting data in all sorts of different ways. We've developed something with GeoNode, which is a open source piece of software, and our guys go out and they obviously map the network. We get as-builts back, and we do that, and then we submit it back through. NUAR at the moment is in development, but how can we as an industry? I mean, this is one thing that we can use. How as an industry can we get all this together and make sure everybody knows where they are? And reference that question earlier, by the way. We talked about that, saying, what about commercial sensitivity as well? What if somebody could just scan the whole area and get your network built everywhere? There's commercial sensitivity about where your networks are as well. Yeah,
well, first of all, what we do, of course, is contractors who work and who basically map the network that have built digitally. Yeah? So this is just contractors that use our tooling for getting as-built information on an accurate way. I mean, if you really want to do this accurate, you need to use a GPS device. So that maybe, I'm not sure if that's familiar for everybody here. Maybe come back to the NUAR. Yes, I'm aware of NUAR. I must say that I think to maybe first come back to that, I think one of the issues with NUAR, I believe they want to reduce damages. And in my opinion, they will not succeed in that, by the way. And the reason why I'm saying it, in the Netherlands we did that. We have that system, which has been built for, I think, a couple of €100 million. But it still Netherlands has still an immense amount of damages, by the way. And the reason is actually that the data you have is not reliable. That's the big issue, and I think in the UK that is the same. So you basically build an expensive system, and the data that you have in there is absolutely not reliable. And the problem you're getting is that people in the future think that the data that they'll see is reliable, and then that's, I think, one of the issues, for example, we have in the Netherlands. So that's about NUAR, so I'm aware of that. So that's why I'm saying, if you want to do it well, start mapping your data in an accurate way. And I think the only one who can basically enforce that are the companies who have the assets. If they say to their contractors, look, I want that this mapped in the Netherlands, for example, nowadays, the specification that utilities send out is 5 centimeter accurate, within 5 centimeter. Wow. Now that may be a little bit too how do you say that, too narrow. I think 10 centimeters already, I think, very good, if you can achieve that, plus or minus 10 centimeter. And then coming back to the one of about, let's say, how it was phrased, the network
Yeah, somebody could scrub, the system and then gather all the information of where you're at. If it's, let's say, a kilometre radius that you can get the maps for, and then they'll go the next square, and then they'll just build an idea of what your network looks like.
I must say that I think in general, if you look to those systems, so with our system, of course, that's purely for mapping new networks, of course. That has nothing to do with what is existing, by the way. I mean, yes, of course, you can connect our system to so-called EM locators. But I'm guessing you meaning, let's say, if you take systems where you can draw a dig site on and that you get plans back. Is that what you?
No, essentially, yeah. I mean, our contractors use that. I think LS Bud that you mentioned, our contractors use that. But you've got to gather it from so many different sources right now, and then the information just isn't accurate. So all the dig teams, when we send them on the ground, we issue say, no, there's an asset in the area, you can't rely on the line. You've got to hand dig until you find it, and then you can get on with the job.
Yeah, I think most of the time, let's say, first of all, let's say, what I mentioned here in the UK it's a quite common approach, by the way, first of all. In the Netherlands, today, I can also, let's say, ask for a square, let's say, for, it's for 1 square kilometer, and then I get the assets basically. Very accurate. I get them all, by the way. I can maybe get 20 or 30 assets basically, which in that area, particularly if you go in a large city. And I think there is, nowadays in these toolings, of course, there are safeguards that if somebody is making a ridiculous amount of searches, basically, that they basically trigger alarms on that basis. If you can see from the behavior what is questioned, basically, what is asked, if that's a normal request or is that, let's say, a request which is looking, for example, for fully automated, where somebody's really harvesting, let's say, data from asset owners.
Yeah. You could probably base it to the UK permit system for streetworks and just say, is there a permit on that particular area that they're searching for? Anyway, maybe we'll take this offline and chat. But yeah,
it's good, yeah. That's good, yeah, absolutely.
Okay, any last questions before we move on to the next session? Okay, thank you very much indeed.
Yeah, thank you very much, by the way.
Yeah.